Hello and welcome. This is Harshit, and today we'll see the mini solar plant model for our laptop. Now, due to the ongoing pandemic, many of you must have been having online lectures or offices, and one of the problems we face there is power failure due to the power cut. Our laptop discharges and we are not able to attend to our business. In the coming 5 minutes, we will see a simple solution for that. Starting with our laptop specifications, I'll be using an Asus Strix G-Core G531 GT laptop, which is manufactured by Asus Tech Computer Incorporations. My laptop comes with an Intel Core i7 9th Gen processor, and it has a GPU of 4 GB, which is NVIDIA GeForce GTX 1650. Now, the most important part we are concerned with is battery. The laptop comes with a 48 photon 3-cell lithium-ion battery and a cooling system of 12 volt dual fan smart cooling, and the input requirements are 150 watt, which is 20 volt 7.5 ampere AC adapter. Now, we will see the power supply of our laptop. Every manufacturer provides online tools to calculate the power required for the device. Mine is Asus, and this is the power supply, which is 343 volts, which I got for my laptop. I will be providing the link for the Asus power supply calculated tool in the description. Coming to our solar model, the basic and the most important thing is the solar panel itself. We'll be using a 60 watt solar photovoltaic module, and we'll store the energy in batteries of 18 ampere hours. Then we will use a converter or an inverter. We can use either of them depending on the availability, and we will be using 10 ampere charge controller and the load, which is our laptop itself. Coming to the specifications, the load is our laptop, which we'll be using for 3 hours daily, and it is of 48 watt hours. Now, we can use a converter, which is DC to DC boost converter, which will convert our 12 volt output to the 20 volt required input for our laptop, or you can also use an inverter of 100 watt maximum capacity, which will convert our 12 volt input to the required output, which will be using for the laptop. Now, the inverter comes with an usual efficiency of 75%, which makes our load to be of 64 watt instead of 48 watt. Now, for the charge controllers, as we know, I equals to power by voltage. Now, it is 48 by our efficiency, which is 64 divided by 12 volt, which will be the output, which gives to 5.33 ampere. So we will be using one 10 ampere charge controller for this. Coming to our solar panel requirements, we will be using 60 watt solar panel. Now, we have to design our model so that it works throughout the year. So we will be considering the worst situation possible, which is the minimum radiation. The minimum radiation in my hometown is 4.21 kilowatt hour per meter square per day, which is minimum, and it usually is in January. I will be providing a link for a website through which you can calculate the radiation for your hometown. So our 60 watt solar panel will produce 252.6 watt hour per day in the minimum, in the worst conditions, when there is sun in the atmosphere. So we need 192 watt hour per day, so we'll be using one solar panel. Also, we are considering a 1 day buffer only. You can also consider a 2 or 3 day buffer depending on the weather conditions due to rain or cloudy weather. That depends up to you. So with 1 day buffer, and we have a load of 192 watt hour with 12 volt output, which is equivalent to 16 ampere hours power. So we'll be using a battery of 18 ampere hours, which is the general practical value which is available in market. So as you can see the model here, the solar panel which will be converting solar energy into our stored chemical energy, which will be used by our battery, which will charge, and we can use a converter or an inverter, and which will convert it into the electrical energy, and we can use a charge controller so that our device does not damage, and we can supply it to our load. Coming to our budget, here are some expected values which you can find in the market. These items may differ depending on the availability. I will providing the link of them. You can purchase similar items. So the expected cost of our model is 5,435 if we use converter, and 5,734 if we use inverter. Thank you.